Good morning, everyone. Welcome to the third part of the video on data analysis. Let me share my screen. Right. So we had started with the data analysis part, and we looked at in the first part. We looked at something about what is data analysis and what are the different types of concepts present in data analysis. We looked at what is data visualization, what are different types of graphs that we have, and then we also looked at some examples of these graphs used in physics, some problems, okay, how do you interpret them, and we looked at what are the essentials of the graphical constructs. Okay, when you have a graph, you should label the axis properly, legend should be present. We have seen all this. And then the next one is we also looked at appropriate scaling. Okay, and then we ended up there. And then the next part of the video, second part of the video, we started with something on errors and uncertainties. So what are the different types of errors? We had zero error, we have seen parallax error, and then we have seen random errors. Okay, and then we looked at random and systematic error. How do you classify them as systematic and random? And how do you eliminate these errors? That's what we had seen. And then we looked at what is the uncertainty in case of an instrument. So this is where we stopped in the second video. In the third video, we started looking at the handling the uncertainties in calculations, because there was a lot of math involved into it. We need to look into some problems using examples. We looked into this also. Okay, and then we looked at, okay, how do you work out with this math and so on. Okay, what is fractional uncertainty, what is relative uncertainty, what is absolute uncertainty, and how do you convert from one uncertainty to another. We have looked into this also. And then we'll finally stop with the percentage uncertainty. We looked at, okay, if one parameter is given, how do you estimate the percentage uncertainty or relative uncertainty in the cube of it, and so on. Okay, so we were able to successfully do this. And then finally we stop there. And now the topic of the third video is significant figures. Okay, let us begin with the concept on significant figures. This seems to be a short video because I have two more videos based on how do you say which graph belongs to which kind of function. And then you have one more type of video which is on linearizing the functions. If you complete all these 5 videos together, then definitely you will be able to solve any problems in physics that is related to data analysis. Okay, so today I'll be uploading these videos, and from tomorrow onwards there will be one video, one problem exclusively on data analysis for the next 1 week. 5 problems will be put across, and there you will be seeing how these concepts are being utilized. Okay, now let us start with significant figures. What is a significant figure? A significant figure is nothing but it's the number of digits used to express a number which carries information about how precise a given number is known. What do you mean by precision? Let me choose my pen over here. Precision tells you, let us say, for example, you are finding out the time. The stopwatch reading of 3.2 seconds will have 2 significant figures only. See, you have 1 digit here, second digit here. It has only 2 significant figures over here. While if you take something like another stopwatch which is having 3 significant figures, instead of reading 3.2, if you read it as a 3.23, it is a very precise. Okay, it goes until the second decimal point also. So it is a very precise one. Thus we say this has a larger significant figures as compared to this. This is more precise. Okay, so significant figures helps us in understanding the precision of an answer or a number. Okay, so towards it, the next part what we have here is, let us say, some examples over here. 504, for example. I need to change my pen once again. Right. 504, for example, has 3 significant figures. Why? Because the 0 is in between. So there are 3 digits which are necessary for you. Okay, you cannot ignore the 0. So therefore, it is 3 over here. 608,000. So what you can do is you can write this as a 6.08 into 10 power 5. So, but the number of digits which are uniquely required to represent this number is 608. 3 numbers are required, and after that you can mention in terms of the powers of 10. So therefore you can say it is 6.08 10 power 5, or this has 3 significant figures. 200, you can write this as 2 into 10 square, right? As a result of it, you need one of them to be very important over here, because this gives you the place value of the number. So 2 is nothing but one significant figure here. Okay, it's not the value of this number, it is the position where it is been present. Okay, or the numbers, the unique digits which are represented apart from the zero. Okay, the round represents your significant figures. Now here you see 0.000305. Now you see this represents three significant figures over here. These zeros do not carry any value. Okay, insignificant figures. Of course, this tells you about how many thousands it is being divided by this number. So therefore, this the actual value in scientific notation can be written like this. But without this 305, this whole thing will not have any value. So therefore, you are going to consider this 305. If I consider here now 0.005900. So if I consider here, so these two values, these two zeros does not carry any meaning over here. But these two after this will really carry a value. See, I'll tell you an example. If you take, for example, 0.2 and 0.20, which one is more precise? This one is more precise. The reason is because you go until the second decimal point. Okay, so you get a more precision. So therefore, so here also you see 0.0059 will have only two significant figures. But if you put two more zero here after this in the decimal, then definitely this is more precise. So therefore, you should write this as 5.900 into 10 power 5 minus 3 in scientific notation, and this will have four significant figures. Okay, let me move on to some other examples. Now there are several values given over here. We would now like to look into how many significant figures each one of them will have, so that you get an understanding about how to write the significant figures. Okay, then number, so 0.02, how many significant figures? This zero does not count, so it is 1 here. 0.020, how many? So this zero does not count, only this 2 will count, so it is 2 here. 501, clearly 3 here. 501.0, see, any zero after this will not count, so you're not supposed to take this, it's only 3 here. 5.000, I'm sorry, this is 4. 501.0 will be 4 because this is more precise. See, writing 501, 501.1, you see, this is more precise. So this would be 4, and this would be 5.000 into 10 cube. How many? 1, 2, 3, 4. 4 significant figures here. What about this? 5000.0. So now, so this will also have counted here. So this would be 5 here. What about this here? 6052.00. 1, 2, 3, 4, 5, 6. 6 significant figures. Then here, these zeros will not count, right? So therefore, you will have 108. You can write this as 108 into, or 1.08. I'll write like this. 1.08 into 10 to the power of, how much is it? 3, 4, 5, 6, 7. 10 to the power of 7. I can write like this. So therefore, it has only 3 significant figures here. Let us do this one here. So this will have all these 3 significant figures. These numbers, these zeros have no value, because how do I write this? I can write this as 5 into 10 power minus 3, right? 1, 2, 3, 4, sorry, minus 4. Minus 4, so it will have only one significant figure, 1 here. 0.1020, so it has 4 significant figures here. And here, 1, 2, 3, 4, 5. So this is 5 significant figures. Okay, and then next one, 3.50 into 10 power 4. How much is it? See, this is a significant figure, 0, which is appearing after the decimal point, right? So with the number here, so 3.50, this should be 3 here. 2, this is 1 here. 8.4772, 1, 2, 3, 4, 5. This is 5 here. 8040, this is 3 here. And this is, how do I write this? This can be written as 8.04 into 10 to the power of 3, right? And this one, 3.01, 3 here. 80405, how many? 5 over here, because the end number is not 0. So this is 5 here. And this will be 0.0300. So this 0 is not counted. These zeros are counted. 1, 2, 3. So it is 3 here. 699.5. 1, 2, 3, 4. 4 digits here. 2.000 into 10 square. So this is more precise, right? So therefore, 2, 1, 2, 3, 4. This is 4 here. 0.901000. 1, 2, 3, 4, 5. This is 5 significant figures. And here 90100. See, this 0 will not be counted, right? It may be counted only, it will be counted only after the decimal. So there is no decimal here. So therefore, it has only 3 here. 4.7 into 10 power minus 8. 4.7. 2 here. And here what is happening? 0.000410. This is 3 here. Okay. I hope you understood about how to calculate the significant figures. If you have any questions, you can always write it down in the comment section. I'll be happy to answer to it. Okay, now next is while adding or subtracting numbers, how do you consider the significant figures? Very, very important topic, because this is the topic that you need to know while you are answering the problems in your second paper, paper 2 or structured paper. Okay, let us take, for example, if I take one number which is 3.21, how many significant figures does it have? 3.21 has three significant figures. This has three significant figures, and 4.1 has two significant figures. I made a mistake here. Let just a minute. Let me just change it across here. So I can now say, let me use a white pen here. I can say this will have three significant figures and this will have two significant figures. So as a result of it, which one has the least one? So number of significant figures in the addition is 2 over here. So your answer should also be only two significant figures, right? That's why I put 7.3. But in reality, when you add this, what will happen? 4.1 plus 3.21 will be 1, 3, 3 plus 4 is 7. You should get 7.31, but here we represent it in terms of 7.3, which means why? Because amongst this has 3, this has 2. Which one has the least one? That value should be carried in the answer also. Okay, so therefore this will also have two significant figures. Let us take here. So how many significant figures we have? 1, 2, 3, 4, 5. This is 5 significant figures here, and here 1, 2 significant figures here. So what should be your answer? Your answer should have, see, mathematics you do it properly, addition, subtraction, whatever you want to do. But while you get the final answer, represent it with the least significant figures only. So when you do this, what is the final answer you get? You should, if you subtract it, you get the answer as 10.071. But how do you write it? You need to write it only in terms of one significant figure, which you write it as 10 over here. Okay, so the subtracting, so even this 0.0 will not come, you will just write it as 10 over here, right? Then in multiplication or division, so this applies for addition and subtraction. Or in raising, so you have something like this. Let us say 25 will have two significant figures, 10 will have three significant figures. When you multiply this, you get this value over here, which is 25 into 25, which is four significant figures here. See, it does not involve, it does not have something like two significant figures or three significant figures, but it is seen to be four significant figures. Why do you do it? Read this. It says, or in raising a number to a power, the result must have a significant figures as the least precisely known number entering the calculation. Okay, so it should have at least so much, but since this number will be lost over here, if you write this as a 25 over here, then definitely are 2500. If I write this as 2500, definitely it will be lost. Okay, so what we do is you can write it as 25 and four significant figures. Now let us take up here. So you have 1.317, four significant figures here, and 1.2306, five significant here. You get a big line of numbers over here. So what you do? You need to represent it with the least values over here, which is 4.1.07. Here also, I made a mistake here. I'm sorry. So here it is two significant figures, 1013 significant figures. The answer, though you get this as 25, but you need to represent it only in terms of 2SF. So which should be written as 2500 only. I made a mistake in that. Please correct it. Okay. Next, here 12.3 cube. Now 12.3 has three significant figures. Don't worry about this cube here. After you put it across everything, you get this much big answer here. Now we are looking at powers. So what do you get here? You are now leaving all this and you are going to write 1.86 into 10 cube, which once again has the same three significant figures. In essence, what you need to do is, if you are doing a mathematical arithmetic computation, then if you have two or more terms, more than one term, so whichever term has the least significant figures, only that much amount of significant figures should be used in your answer also. Now let us look at this here. Root of 296,000, three significant figures. These zeros should be neglected. So when I give this, you get the answer as this much long. But what are you going to do? You are going to write it only in terms of 3SF, which is 1.72 into 3 into 10 square, right? So I hope you would have understood the significant figures in manipulating numbers in addition, subtraction, multiplication, division. If you still have any questions, you can always get back to me. With this, we come to an end to significant figures. Two more videos are there. One is for the graphical analysis, which we need to know about what are slopes, areas, intercepts, pixels, what are error bars, how do you get these error bars, what is that you can derive from an error bar, and how do you handle uncertainties in graphs. So far what we have done, we have handled uncertainties only in the equations. Okay, we need to handle the uncertainties in the graphs also. Okay, so let me continue with this video in the next video, that is in your fourth video, and see what this can be done. Okay, thank you very much for your patient listening.